So I thought what we'd present today, or I will present today, is looking at a post-pandemic world through the lens of the activities of Annex 79. So Annex 79, as you heard, is about occupant-centric building design and operation. And so I'm going to focus this presentation largely on telework and the very broad energy implications of that. And then I'm going to look at some specific activities that Annex 79 is working on and how these concepts and workflows and technologies can be applied to improve energy performance of buildings and comfort as well. So if we look at telework very broadly, there are many energy implications, and historically we focused on transportation. But as we've seen, especially in the last few years, there's major implications for buildings as well. So I'm going to focus on 4 domains. So the first one is transportation, and that was the main impetus for telework back in the 1970s when the idea first gained popularity. But we'll also look at office buildings, homes, and the technology and software and infrastructure required to exchange data between people and machines. So, as I mentioned, telework has been studied since approximately the mid-1970s. And right before the pandemic started, I wrote a literature review on the question of does telework or telecommuting actually save energy? So that's available in the Journal of Energy and Buildings. And then incidentally, we had a good case study, if I can call it that, for understanding and quantifying the impact of telework. So if we consider a sort of theoretical framework, if we start with the status quo in terms of no telework, what is the energy use for that? Of course, there's significant savings from transportation energy because we're no longer commuting to work. And there's some savings in our office buildings because if our office buildings become less occupied or even vacant, and as a result, we can use less office space that has positive implications. And so together, these represent the maximum potential. But then we have a lot of so-called rebound effects that reduce the effectiveness or reduce the maximum potential savings. So the first thing is we're still consuming energy in our office buildings for reasons I'll get to in a few slides. Now our home offices and our entire homes in many cases are increasing their energy use because we're there more. And during COVID, even children were there more and so on. So overall higher occupancy. There's a lot of rebound effects in transportation that we'll talk about in a moment, such as now you can no longer incorporate your errands, your grocery shopping, and your children-related activities and trips into your commute. It's a separate trip now. And there's added energy related to moving and managing and storing data. So the net benefit or net savings is actually significantly smaller than we might expect. So before COVID, 24 studies had tried to look at this problem. But a major limitation of those studies is they didn't look at the whole picture. They looked at one aspect, and oftentimes they use surveys which are potentially biased from self-reporting. And the other thing is that telework was so uncommon, relatively speaking, that we just didn't have a big sample. So the effect size was pretty small. So what I'm hoping to do in this presentation is reveal new insights based on what we've seen in the last 2 years. Before I move on, it's worth noting that this is a very challenging problem because in research in these large problems, we need to consider where are the boundaries of our study. So I'm going to focus on, as I said, homes, offices, transportation, to and from work, and ICT. There's also the temporal scope. So do we think about just decisions that individuals make each day? Or do we start to consider the long-term decision making? Like I will buy a new home, a larger home. Perhaps I'll buy a bigger vehicle because I won't be driving as much. So those long-term decisions are equally important in my opinion. We tried to, and I won't go into the details here, but we've tried to map out all the linkages between domains. And in brief, it's very complex. People's decision making, for example, does not just include their own considerations, but also those of their family members. And so if I don't drive to work one day, now my car is available to all my family members who may do a long trip for any number of activities. So there's many linkages between the different aspects. This is a non-trivial problem. Just one example, a recent article in the Wall Street Journal showed that the reoccupancy or the occupancy of office buildings in various American cities is fairly closely linked, lots of noise clearly, but fairly closely linked to the average travel time to work in that city. So there's a downward trend here where the longer it takes the average person in the city to get to work, the less likely the offices become reoccupied. Regardless, you could see the office occupancy is around 40 or 50%, so quite low. And in Manhattan, one specific case, we could see that office occupancy is increasing. Not that we're at the 35% compared to pre-COVID. And so let's look at each of these domains in a little bit more detail. So in office buildings, the layperson would assume that empty building means no energy use. But of course, that's not true. So there's some minor energy benefit to having fewer people. But the extent to which the benefit occurs depends on how the space is managed. So for example, do we consolidate people and rent out some of the space? Is the ventilation controlled based on occupancy? Are the set points, are the lighting controlled based on occupancy? Is there a sleep mode for the electronics so that they turn off during vacancy? At least from my experience, it's relatively surprising how little our buildings save energy despite being vacant. A lot of equipment stays on. And on top of that, the few people that are there expect very high ventilation rates. So the ventilation might be running at full capacity as if the building is full, and even more ventilation than is required because of COVID and the fear of transmission. So an early result right after COVID started, at least in North America, suggested that the energy savings in office buildings was only about 25%. And I suspect this has gotten a little bit better. On the other hand, again, with the fear of COVID transmission, ventilation rates are also going up, which is driving energy use higher. So the savings are relatively modest. In general terms, we expect an office building or a commercial building in general to have some base load regardless of occupancy, and then we expect an upward slope. And so one of the ways we can look at a building's performance is to look at how sensitive it is to occupancy and what is the base load of that building. Ideally, the base load would be zero, but at least in my climate in Canada, that is not possible because if you turn off all heating, the pipes will freeze, and so there's major implications here. But an interesting study that came out about 5 years ago looked at this for different buildings, and you can see for 4 different university buildings, both the slope and the base load are tremendously different. So I think this is a pretty powerful way to understand performance of our buildings going forward. This is only possible if we can measure occupancy, which is one of the goals of Annex 79, to improve our ability to measure occupancy. In the home, past research suggested that energy use would increase by between 0.1 and 20 kilowatt hours per day that a person teleworks. This range is enormous, and some of this is because of climates and housing type, but a lot of it is because it's simply uncertain. There are many questions in the literature. How do you use your lighting? Do you heat and cool your whole home? Are other people present? Because one of the reasons we don't save that much energy when we leave our home is because many households have retirees or children or other people present. And so it's actually not the norm to have an empty home during the day, it turns out, because of multi-generational families and general demographic trends. So whether we save energy depends a lot on how we operate our heating, our cooling, our lighting, and so on. We saw during the pandemic many people doing laundry and baking and other energy-intensive behaviors during the day. And in Canada, at least, and certainly other parts of the world, we usually heat and cool our entire home as one, which means even if we have one person occupying a small part of the home, we usually need to heat and cool the entire home to keep that one person comfortable. But another big thing is that people want bigger homes, and we've seen this in the market, in the housing market. People have generally chosen to upgrade homes where they can, and that often has affordability implications, and it even has implications on where they live within the city, especially in the North American context, where usually bigger home means moving farther away from cities. And so we obtained some data from our local utility in Ottawa just for homes, and we found on average, the average home increased in electricity use by 12.1% between the year before COVID and the year after. But maybe more interestingly, the peak loads increased significantly, about 15 to 20%. The timing of the peak loads also changed a little bit more towards the middle of the day versus morning before work and evening or late afternoon when people are returning home. And we performed a survey to understand what are people doing at home and how has their behavior changed. And unsurprisingly, many of these activities, computer use, entertainment, cooking, lighting, these have all increased significantly. Some people reported less laundry, which is expected, I believe. We also surveyed people on whether they purchased more appliances and electronics, and unsurprisingly, many people had to purchase new computers, more computer monitors, etc., to work from home. I think a concern that we should have as a community is air conditioning use, because as people work more from home, if they had air conditioning, they'll use it more to keep themselves comfortable. But perhaps even more concerning, there's people like me who purchased and installed air conditioning in my home, central air conditioning, because I was uncomfortable during the day for the first time, because I'm home for the first time during the day. And once people have air conditioning at home, they of course will start using it more often outside of work hours. So while this study I performed a few years ago is slightly old, I think it's another reason for some concern. So in Canada, the energy performance of the average home improved significantly when we measure it per square meter. So from 1990 to 2015, we saw about a 35% drop in energy use intensity. And similar for emissions, actually a little bit better for emissions because of the cleaning of the grid. But during the same time, the floor area per person increased 27%. And this is a combination of bigger homes and smaller families. The combination of those means that the energy use intensity, when we normalize per person, not per square meter, dropped only 18%. And so this, I think, should be a big concern, because as we move forward, if we continue to work from home and use our homes for more than sleeping and eating and some entertainment, then we're going to see bigger homes, and this has major energy implications, also affordability. So while these data are somewhat inconclusive, it seems in the US, there's an uptick on average floor area. And quite surprisingly, the average floor area in American homes, new homes, apparently is about 2,300 square feet. So something like 1,100 square meters, or sorry, 110 square meters. So, sorry, I got that wrong. 210 square meters, very large, I think, especially as our homes are decreasing. Major implications for transportation as well. And while this is seen as one of the benefits of telework, there are some studies that suggest transportation use goes up as a result of telework. There's a lot of reasons why. It's very complex. This is, again, a behavior issue, although it's perhaps outside of the scope of Annex 79. But there's, when people start teleworking, there's fewer opportunities to chain multiple trips together. As I said before, if a teleworker, if a worker is not using their car, then it's available to other people at home. We may be able to justify larger cars or more cars because we're less concerned with fuel use. I think one that we should be very concerned about is suburban sprawl, the idea that people will move outwards from cities because there's no longer as much incentive to live close to the workplace into denser areas. And ironically, if telework leads to less traffic, which it probably will, then there's less resistance for people to drive because there's less traffic in the way. It's also unclear what happens first pre-COVID, whether teleworkers are now more likely to move outwards from cities and built environments, or whether people who live in the suburbs or even the exurbs are more likely to telework. So it's a little bit of a chicken and egg situation, and the literature is a bit unclear on that. But we should be very concerned, especially with sprawl. This is a classic graph that just shows the relationship between fuel use for transportation and population density. Unsurprisingly, less dense cities are associated with much more fuel use. And so there was a time about a year ago, or maybe 18 months ago, when all the headlines said, people are leaving cities, you know, our city's going to die. And it's rather positive, I think, that this has proven not to be the case by and large. But that was a concern not too long ago, and now we're seeing a reversal. Of course. During COVID, or sort of peak COVID, maybe a year ago in Toronto, as just one case study, what we saw with housing prices on this left graph is that the further out you went, within reason, from the city of Toronto, Toronto is this lighter region here. So this is maybe 50 to 100 kilometers away. Housing prices went up significantly in those far-reaching suburbs, places where you could theoretically drive to work or commute to work every day in Toronto, but still quite distant. This is a problem because if we look at a very similar map although it's over a decade old, we see that those regions are associated with the highest greenhouse gas emissions, essentially because they're driving further distances and there's very little use of transit as well as larger homes. I won't dwell too much on the ICT part, but it's worth noting that while ICT uses some energy, and very significant in some cases, it's also an enabler of teleworking. So overall, probably a positive contributor to society. So data transmission uses something like 1 or 1.5% of total electricity use. This is significantly used per byte, and these things are counteracting each other. There's a lot of uncertainty about data we use for using things like Netflix and other streaming podcasts. The field study I've done, it's very hard to distinguish what the data is being used for without breaching privacy. But this shows the sort of trajectory of internet traffic. It's very significant. So of all the literature, most studies suggested there is some benefit. This is in kilowatt hours per teleworker per year. There's some benefit overall in teleworking, but there's tremendous, especially as we start to bring in other factors like the home and transportation and these rebound effects that are not as obvious. So I'd like to briefly introduce IEA EBC Annex 79. This is the annex that I co-lead with my colleague Andreas Wagner from KIT in Germany. The last time we met as a group in person was almost 3 years ago, but we are a very large annex on the order of 100 people and growing. So it's a very popular topic because we have people looking at comfort, controls, data-centric methods, building design and simulation, and so on. Our annex is divided into 4 subtasks, and the first looks at comfort, especially considering multiple domains of comfort, so thermal comfort, visual comfort, acoustic comfort, and indoor air quality, and how these relate to each other. That's fairly novel research. These are traditionally looked at separately. We have a subtask, number 2, looking at data-driven strategies. The third subtask looks at building design, especially in occupant-centric ways. And the last subtask, number 4, looks at occupant-centric controls and operating strategies. As much as we have a lot of people involved, we also have a lot of countries. So there are major implications here between telework and what our annex is doing. And I'd just like to show some highlights. So first of all, expectations for comfort are significantly different because people have become accustomed to ergonomically friendly furniture, flexibility, complete control over their indoor environment, etc. And that will be largely taken away from them as they move back to the office. And here's just some examples of some kind of news items. So this was in a Toronto building where the office building put in the lobby this sign that says, Mr. Sweatpants Yet. In other words, sort of a reminder that you can no longer wear casual clothing because you're now in an office environment. This was taken down very soon after because it was very unpopular. A very recent article in the Wall Street Journal found that a lot of employees were uncomfortable when they came back to the office because they were used to being able to control the temperature exactly as they wanted, and and with fans and open windows, and a lot of those opportunities are taken away from them. So I think we're going to see a workforce that is much more spoiled and has much higher expectations for comfort in their office. Similar one, but about dogs. And so just as one example study that we did under the Annex, we looked at acoustic comfort in buildings, in multi-unit residential buildings. Two big things happened during COVID. One, people are working from home, but as a result, the second thing is that more people are there making noise for other people. And so we looked at how noise levels and how annoyance of noise levels has changed, and we're seeing big differences, big increases in annoyance from neighbors, from things like impacts on ceilings and noise transmission through walls. Traffic reduced, that was a small positive benefit. But a lot of our homes are not really designed for providing quiet environments during the day. And so this has major comfort implications. Our data-centric subtask recently wrote a literature review on data in urban environments and in the built environment in general. But our annex is looking at how can we leverage all these different data sources, whether it's at the room level or the building level or even the city level, to improve how we design and operate our buildings and even to some extent our cities. Our subtask on occupant-centric design is developing new workflows such that we can apply simulation in novel ways that incorporate and even report on things like thermal comfort, visual comfort, well-being, indoor air quality, etc., simultaneously. Because as I said previously, comfort was often looked at in isolation, and we're developing ways to bring this under a single tool and framework so that we can understand trade-offs between energy and comfort and different forms of comfort. The occupant-centric controls subtask is looking at a few things. One, how do we better collect information from people? So for example, there's this smartwatch interface called Cozy from Clayton Miller, where people can vote on the comfort level on their watch. And this can integrate with the building automation system to try to provide better comfort. Because we have a whole population of workers who are now expecting much higher levels of personalized comfort in their office. And I think a lot of office buildings are not equipped to provide that. And on the more sophisticated end, we're also looking at things like how can we learn from people? How can we study multiple sources of information, like how they interact with the building, to try to provide more comfortable conditions, whether or not we prompt them by voting or interacting, or whether they just passively interact with the building. We can learn from both of these things. We're also looking at other forms of control, like controlling ventilation, temperature, and lighting through occupancy sensing, or again, through polling. So just one example of some policy implications for our annex. We look quite a bit at building codes and how they discuss and kind of require us to design for occupants. It seems obvious that our building codes should talk about occupants a lot, but in reality, they talk about occupants in very abstract ways. And so we're sort of scrutinizing building codes in this regard. And then we recently wrote a review looking at 25 different building codes around the world. But I'd like to show just one example. And so this is a little bit abstract, speaking of abstract, but what we're looking at is a simulation where we have a large group of offices, probably not a very nice office environment because of the size of it, but it's just a simulation. So on the left, we have a 24-hour cycle of occupancy simulated. This is quite typical based on measurements. On the right, we have the lighting that would be required if the lighting were automatically controlled such that as long as there's one person within the set of 4 cubicles, that the lights will be on. And so we actually recommend something like this because it's fairly high resolution of controls. On the other hand, if we have, sorry, I'll just have to go back. If we have very coarse controls, the efficiency is much lower because even if there's one person present within the group of 25, we need to have the lighting on, as an example. And incidentally, this level of resolution is more similar to what we see in North America for lighting requirements. So as our buildings become less occupied, which I think is somewhat inevitable, we need to look at how to mandate occupant-centric controls a little bit better. We're also looking at occupancy and how can we predict occupancy, how can we design our buildings and operate our buildings better for occupancy. So this is a little bit more in depth than I'd like to go into in this presentation, but the point is our buildings, even pre-COVID, are often designed for peak occupancy, and that's what the codes sort of mandate and our way of design thinking mandates. But the result is that our buildings tend to be oversized for most conditions. So much the way HVAC is sized for the worst case scenario, we often design buildings for the worst case occupancy scenario. But I think there's a lot of opportunities to look at probabilistic design and think, okay, if we're willing to accept that 1% of the year our building might be overoccupied, we can get away with a much smaller building footprint. And with that, I'd like to thank you for your attention, and I'd be very happy to take any questions. Thanks very much.